In case of a lengthy or permanent outage at the AWS region hosting your cloud applications, you must have a robust plan in place to continue your business, minimizing both downtime and data loss. And because the possibility of a disaster is remote but not zero, you also want to minimize time and money spent developing this plan. This video shows a demonstration of do-it-yourself disaster recovery for AWS, in particular how to replicate, test, and fail over mission-critical EC2 instances across physically remote regions using video captures from the AWS console. First, let me start with an overview of the basic strategy as a roadmap for the demonstration video. Given your mission-critical workload at your primary region, shown on the left of this picture, the end goal is to choose a DR region for your instances, shown on the right. Provision identical instances in a similar VPC in your DR region, periodically snapshot data to the DR region, and in case of a disaster, merely power on the replicas. Specifically, the steps are: for a given instance, create a duplicate instance at the DR region from the same AMI. Snapshot the primary instance's volume, or volumes if it has multiple disks. Copy the snapshot to the DR region. Create a volume from the replicated snapshot. Replace the DR instance's attached volume with the new replica so it has a timely copy of the same data. Then repeat step 2 on a periodic basis to keep the DR instance up to date. Repeat all of these steps for all mission-critical instances. Then, if the primary region is down, merely start the DR instance. To reroute clients to the DR region, you can use Route 53 DNS to update fully qualified domain names to the public IP addresses at the DR region. That's the theory. Let's go through it step by step through the AWS console. The first step in protecting an EC2 instance against disaster essentially involves launching a similar EC2 instance at another region with the same settings as the primary. To do so effectively, you need to know the following prior to launching the DR instance: the AMI on which the primary instance is based, so you can choose the same AMI at the DR region. For example, this may be from the AWS Marketplace, or the community, or your own custom image, in which case you would need to replicate it to the DR region. The size of the primary instance, so you can size the DR instance similarly. The VPC to which is it attached, so clients will be able to route to it. For example, if it is the default VPC with a public IP, or a custom private network. If the latter, you may need to set up a similar VPC at your DR site in advance. Security, the security group settings so clients are permitted to connect through a firewall. In the example here, I'm protecting a small Bitnami LAMP server from the marketplace, which is hosted in Ireland attached to the default VPC and visible only to my IP address through the necessary protocols. And I'll be creating a duplicate one in the Paris region. Given this information, the first step is to navigate to the marketplace to search for the same AMI and to deploy it. Here I'll choose my DR region, in this case staying within the EU in Paris. Choosing the same size as the primary, the default VPC in Paris, and we'll create a security group setting. And we'll create a new key pair. Once the deployment is complete, stop the instance so you don't incur running charges. It is only necessary to run it briefly during a test, and then, if necessary, indefinitely after an actual failover. Testing disaster recovery is arguably equally important as an actual failover. You do not want to try to power on your DR instance for the first time in an actual emergency without knowing that you've tested it before. If some mistake was made, all of your cost and effort was wasted. And remember, you are protecting an application or a service, not just an EC2 instance. So you want to make sure whatever application is hosted in the instance can recover properly. Take, for example, MySQL in the LAMP server. I want to make sure that on a failover, the database is accessible. To be able to test this, you might consider creating a test table with a timestamp that is automatically updated every minute. On the DR site during a test, we will verify that the table is not only available, but is reasonably up to date. SSHing into the primary MySQL server, which will be replicated to the DR region, I can connect to my database and I can look at the table that was created. This table has just a single entry that's a timestamp that's updated with a schedule that I created within MySQL to update every 1 minute. So when I do my DR test at the Paris region, I expect to see the similar table with a similar timestamp updated as well. The DR image, while provisioned, has no actual user data. So the key next step is to replicate data from the production instance to the DR instance. To do this, I will create a snapshot of the primary's volumes. In this case, there's one volume, the root disk. Copy the snapshot to Paris, create a volume from that copied snapshot, and swap the old volume with the new one. The first step is to create a snapshot of the production instance's volumes. First, identify that instance's volumes by going into the details and identifying the disks. In this case, there's one device, the root device. Details on the root device shows what volume it's made up of. So click on the details of the volume, select it, and select Create Snapshot. A useful description will be what the snapshot is for, and also the name of the device I'm snapshotting, because we'll need to remember that when attaching it to the DR instance. Once it is complete, copy this snapshot to the DR region. This will incur some cost, but it is the only way to get data between two regions that is application independent. Select the snapshot, right-click, and select Copy. Choose the destination region, in this case Paris, and give some information to remember what this snapshot is for. Now navigating to the target page, in this case Paris, we can go to the list of snapshots and we can see that this replicated snapshot is in progress. It may take some time depending on the size of the snapshot and the distance being covered, so be sure to refresh it frequently. When the snapshot is complete, I'll create a volume from this snapshot and attach it to the DR instance, since this snapshot has the latest data. Volumes must be attached to instances in the same availability zone, so before creating the volume, we need to determine which availability zone our instance is in. In this case, it's EUS3C. Going back to the snapshots page, from the snapshot, right-click, select Create Volume. Select the correct availability zone. In this case, we want to keep track of the device again that we're going to call this eventually, and we'll create the volume. The volume is completed when it's available. Now we'll detach the old volume from the DR instance because it has no data on it that we want. We'll navigate through the details, find the devices, click on the volume, verify that it's the one that's in use. Remember its name, OEF38. We'll detach this volume. Now it's available. Then we find our replicated volume. the new one that we just created. It's available. And we'll attach it to our DR instance. Making sure we call it the same name as the original volume. Once it's attached, we can start the instance to test that it can boot and all the necessary infrastructure has been correctly configured. It should transition to running. And after it does so, ideally, as a test, I can connect to it and make sure the application inside is available. In our MySQL example, I can check that the auto timestamp table is there to make sure it is accessible and reasonably up to date. To do so, I wait for it to transition to running. I get the public IP address. And in the same way I looked at the SQL server in Ireland, I can connect to the MySQL server in Paris. Looks good. Now stop the DR instance because it's no longer necessary to run it and you want to minimize your cost. Clean up the replication by deleting the primary and replicated snapshots and the original detached volume from the DR instance. They are no longer necessary. The available one is the one we detached, so we delete the volume. And the replicated snapshot is no longer necessary. Plus, back in Ireland, the original snapshot that we created is also no longer necessary. Then, repeat this process on a regular basis to keep the DR instance up to date. Back in Ireland, find the devices, click on the volume, take the snapshot, replicate the snapshot, create the volume, and swap out the disk at the DR site. Again, testing while at the same time minimizing time and cost is key to confidence in the entire environment. Now, if you do need to leverage your DR instance in case of an extended or permanent outage at the primary, merely navigate to your DR instance, in this case in Paris, and merely power it on. You've been testing it regularly, so it should start, your application should start, and clients should be able to connect to it via an appropriate VPC and a correctly configured firewall. And failback is merely performing the same steps as we just did, but in the reverse direction. In particular, if you're on a public network and you have a Route 53 DNS address, you can update the DNS address to the public IP of the DR instance so that clients will resolve to this address to the DR region and eventually connect there once the time to live of any cached resolution has expired. In this case, we can get the public IP of the DR instance, go to the Route 53 console, find the DNS name of this particular instance, and just update it. This runbook works at the storage level by taking snapshots, so it's the same approach for any application hosted in an EC2 instance. Perform the same operation on all your mission-critical instances, and you have just accomplished do-it-yourself disaster recovery across AWS regions. Thanks for watching this demonstration. Hopefully your takeaway is that it's possible to configure disaster recovery for EC2 yourself through a series of manual steps in the AWS console. However, another takeaway is that these steps are cumbersome in terms of the time and effort you must spend to perform them regularly. Many vendors sell automation solutions on AWS Marketplace, but you might be shocked at the high cost to automate something that this video just showed can be done by hand. But there's one solution that provides the sweet spot, Thunder for EC2, from our company Thunder Technologies. We understand that you want to protect your cloud investment. You might not have time to do it yourself, but you don't want to pay a lot of money for someone to automate it for you. Our solution is just a $20 per month subscription fee to provide all the services demonstrated in this video through a simple, intuitive interface. To find out more, check out our website at www.thundertech.io. Or if you have a few more minutes, please check out a brief demonstration video of our product that is linked here. Thanks for your time. If you have further questions, drop us a note at info@thundertech.io. Thank you.